We'll go ahead and get you guys started. So I think we've had a lot of kind of offense-oriented talks today. You guys enjoying the talks today? Yeah. All right. Woo! That's what I like to hear. So last but not least for today, we have, I think it might be our first defense talk today, possibly, which is something you always have to think about. So we have Trapping Hacks with Ensnare by Scott Behrens?
Yep.
Great. And Andy Hoernecke. God, I thought I was going to get it right. So this is Scott's a twofer. So he's going after Deviant's record. Only like four or five more to go. So anyway, big round of applause, everybody. Thank you.
Cool. All right. Is we good? Cool. So we're going to be talking about Ensnare, and we'll just kind of start off with a quick bio. My name's Scott Behrens. I work as a senior application security engineer at Netflix on the cloud security team. Kind of a combination of breaking and making. Actually, while I'm at it, just a quick poll of the audience here. How many people here do AppSec or application security stuff, either making AppSec stuff, breaking things? Hands, okay, handful. How many are developers or code in some sort of language? Any Rails, Ruby folks out there? Okay, cool. All right. I'm also do tons of security research. Spoke at a handful of conferences and like drumming, cooking, all that sort of stuff. My Twitter handle is HelloArbit. So I don't tweet a whole lot, but feel free to say hi.
And I'm Andy Hoernecke. I'm also a senior application security engineer at Netflix on the cloud security team. I also do research in data visualization and security. I love to travel, so I'm really happy to be out here this week.
So why are we here? We're here to talk about Ensnare, which is an open source Rails gem that Andy and I have recently released. It provides web application attack detection and response capabilities. It requires minimal configuration. It's also super customizable. You can grab the beta here, so we have the link there. I'll give you guys a second to kind of jot that down or make sure you guys can get it after the conference. So, we're really here to kind of talk about how things are in the security industry, and as we can see here, things aren't really so good. These are all the companies, I think, since the beginning of 2014 that have had some sort of breach or some sort of information exposure, and this is just a small subset of some of the companies that have recently been discussed in major media outlets, right? And so I guess the question we can ask ourselves is, are we really winning the race here? It seems that data breaches are just happening like every single day. And as we see that attackers are getting quicker at compromising systems over the past 10 years, and this is a quote from Wade Baker, basically says that the bad guys are winning at a faster rate than the good guys are winning. And I think that we can all kind of agree that that does seem to be the case. So why is this the case? I think it's because the complexity of attacks. It seems that responding to attacks is pretty hard. So we have traditional attacks, things like SQL injection, cross-site scripting, attacks that have kind of been in the OWASP top 10 for forever. We also have business logic attacks, which are super hard sometimes to detect and respond to. We have direct object reference, right? That's pretty easy to find and discover. Also kind of hard to detect, though, potentially. Authorization, authentication attacks, distributed denial of service, right? Sorry, I'm having a little bit of a difficulty with the remote here. I know, I should just do that, right? That'd be way easier. So I think one of the reasons that this is the case is that application complexity has really kind of, applications have become quite complex these days, and their environments have gotten extraordinarily complex. So like, at Netflix, for example, where Andy and I both work, we have an agile development shop, so we're doing tons of deployments every day. We have certain applications in certain regions that might be running different versions of code. We're running A/B tests, so some users might be experiencing a different set of code than other users. So we have a lot of things going on, and it gives us a lot less time to actually catch and remediate vulnerabilities. And I think that the solution to this problem is, as an industry, we tend to think that we can solve everything with a new appliance. Like, let's just throw some technology up at it. This is a quote that says the industry has long needed a bot wall. Does anybody know what a bot wall is? You know what that is? Do we need it? So I think that we're kind of in this place where, here's a kind of a comic that represents that kind of, I think, where we're at in the security industry. So tell me again, why do we need your security appliance? We already have a WAF, load balancer, firewall. We have a bot wall and a behavior analytics engine. Yeah, but in ours, the lights are blue. Take all my money, right? So I think we're just kind of at a place where we just want to throw stuff at it. And our philosophy, at least in the context of application security, is that application security really starts in the application, right? So we try to encourage people to do secure coding, security awareness, perform some pen tests against your code, all that sort of stuff. And I feel like new tiers of appliances, they can be useful, but they often increase complexity in the environment, and they mask the underlying problems instead of solving them, right? So we often feel that the best approach is really just to start with inside the application. It's probably the best place to identify and actually handle the attacks that might be going on. And so what do these attacks actually look like? Well, it really depends on the techniques that are used. So if it's a manual attack, it tends to be a little bit slow, maybe a little bit more targeted. If it's an automated attack, it tends to be fast and all over the map. And how are most web vulnerabilities exploited? Well, through the manipulation of things like headers, cookies, parameters, path, maybe the order operations within a flow that you identify in a web application. In general, you have to actually identify the vulnerability in order to exploit it. And so we'll kind of just step through what an automated scan might look like. These tend to be a little bit easier to detect, I think. They're likely to include a much higher velocity. You're going to see lots of unusual or invalid requests potentially. Many of the requests are going to be for pages or functionality that doesn't even exist within your application. So automated scanning logic is, typically, maybe I'm the user setting up the automated scan. I'm going to manually browse or spider to the site for some amount of time. I'm going to create some exclusions. I don't want to log my automated scanner out while I'm running the automated scan. I'm going to inject some faults and examine responses for signs of vulnerabilities, right? So here, I just picked some page on Netflix.com and said I'm going to run a scan, and here's some of the behavior that the automated scanner did. This is for burp. Did a sanity check. Basically making sure that the site's up, did some policy HTTP checks, started doing some parameter checks, and started doing some cookie checks, and so on and so forth. So what kind of observations can we make about that scan? Well, it looks like it's kind of predictable, right? It's kind of doing stuff in a specific order. Every time I visit a page, it's going to run those checks in that specific order, at least with burp, which is one of the more, I guess you could say, basic scanners, and ones that we often see run against our sites, for example. It's going to check some policy files, check parameters, cookies, headers, refer, and it progresses kind of linearly. Manual testers tend to kind of do this a little bit differently. They use a combination of the browser, proxy, scripts, some command line tools potentially. It's going to include some targeted scans, I would imagine. Testers probably looking for things like user input that's being handled unsafely. What kind of edge cases might we identify in the application? What are some hidden or less visited areas of the site? What kind of observations can we make about the manual attacker? Well, exploit attempts are likely to be seen randomly throughout the attacker session, right? So you're kind of browsing the site for some amount of time, you're clicking around, and then you're maybe fuzzing a couple fields here and there. So there's going to be fewer overall requests, potentially lower velocity, but at the end of the day, it's basically the same techniques and detection strategies. So how do we catch these attacks, right? Well, we can write signatures. We all know how well those work. We can do exception handling. That tends to be pretty decent, right? Things like checking for invalid paths, maybe incorrect data types. Hey, why are you putting integers in a data type that it should be a string? Or we can do existing security functionality checks. So things like we tend to write authorization checks in our code. I should not be able to access your profile. You shouldn't be able to access mine, potentially. And what else? Another mechanism we could potentially use are things like honey traps. And these are basically tripwires that dynamically change and entice an attacker. And we think that these will work pretty well for manual attackers. They don't really have any impact or underlying application functionality, and they allow you to take notice of bad behavior within the application. So let's take a look at what a honey trap might look like. So here we have, I don't know if you guys can read this in the back, but I basically took, using burp the proxy web application, and I'm taking a look at a cookie here that might be interesting. It's admin, right? Now, if you guys are doing an application assessment for somebody, and you saw a cookie that said admin equals false, how many of you would flip it to true? Let's just be honest here. Yeah. I mean, I know it looks a little obvious, but like, come on, right? You're going to flip it to true. You're going to see what happens. And we kind of take advantage of the fact that as, security assessors or even black hat hackers, we're curious, right? We want to see what happens. Here's another parameter. This one is a UID parameter. and it's for a post request to, to perform some action against the site. If you guys saw this UID 26106, how many of you would maybe increment it or decrement it during an assessment, right? Like pretty much everybody, right? So once again, we're kind of taking advantage of that. To be honest with you here, these are what we're actually doing with these honey traps. This is stuff that isn't going to affect the application. And so there's actually been a little bit of prior work in the honey trap area. Mod security actually has support for this. It's just a little bit complicated to set up, and you have to support mod security in your application environment. App Sensor was an OWASP project, a Java project that tried to tackle this problem. Tons of cool features and stuff, but requires Java. Mykonos was a commercial product. We haven't really seen any action from these guys. It doesn't look like things have really been updated since 2011 or so. There's some other WAFs and IDSs that have some functionality in this space. But we really wanted something that was really easy to use, that we could use this honey trap kind of technology with. We wanted to have really advanced response handling, and we'll be kind of talking what we mean with that. But basically, kind of technologies and techniques we use to confuse the attacker while they're potentially performing an attack. We wanted something that was extensible. We wanted something we could track metrics in, and something that also worked within the app layer. We really wanted it to be effective at thwarting both automated scanners and manual testers. Enter Ensnare. And so the way that Ensnare works is it sits alongside the application, and it examines requests that come in. It logs bad behavior, and we define that as violations. It responds to the bad behavior optionally. You can kind of just use it as a metrics collection tool, or you can use it to really screw with the attacker. And it's also set, and then at the end of it, it actually sets these traps to catch hackers on new responses from the server.
So I'm going to walk you through a little bit of how Ensnare actually works and what we've actually implemented in this framework. So we'll start out with a little background. A standard web application, when someone makes a request, the browser will send that request to the server, and the server is going to take that information, determine what output it needs to send back, and render back a response. And with Ensnare, what we've done is we've added a couple more steps. And so I'll walk through each one of these so you kind of know each of the different steps that Ensnare is going to perform. So again, we start with a request, and then as soon as the server receives that request, we're going to start by checking for violations. And as Scott mentioned, a violation is basically anything in the request that might be malicious. So we could be matching on a signature. We could be noticing that the user has gone to a bad path that doesn't exist. So maybe they're running something like a directory busting tool, and they're trying to find admin paths or just files that don't actually exist or could exist on your website, but they shouldn't have access to. Or they could have tripped something like a trap, which we'll talk about a little later. Or really, we've made Ensnare so it's very flexible, and you could input any custom logic you wanted here. But anyways, if any violations are found, we're going to start here, and we're going to log those violations to carry on to the next steps. So the second step is we are going to determine the threshold that the user, that the requester falls in. And basically what this means is we're grouping different people that are making requests to our website into groups. Are they good users? Are they legitimate users just using the site normally? Are they users that have done a couple bad things, like maybe flip that admin flag to true and changed a parameter or two that maybe they shouldn't have? Or can we tell that they're actually really bad because they're really scanning our website hard with something like AppScan or Burp? They've made tons of bad requests, and we know that they're just essentially trying to exploit the site or find vulnerabilities. So in this step, we determine how bad they are and how we're going to respond to them based on that. So step 3 is actually to run whatever response we need to send back to them. And basically this means if we've identified that this user is an attacker and that they're at least a little bit bad, we might want to do something different than just render back the native response that the application would usually send. So this could be something like modifying the response, so changing the content of the response that goes back to the user. It could replace the response entirely, so maybe instead of sending back the user's account profile, we're going to send back a 404 and make it look like it doesn't exist anymore. Or maybe we're going to do something completely custom, and we'll have some more examples to walk through in a little bit. And then, so the final step is to set traps, right? So Scott talked a little bit about this concept of honey traps. This is where this comes into play. We've gone through kind of the set of responses up to this point and decided what we're going to send back to the user. So at this point, we decide, okay, are we going to inject some type of a trap into this response as well that the user might trip? So are we going to add a cookie to the user's session? Are we going to insert some type of a form parameter in any forms that the user is getting back to see if we can identify them as, attempting to manipulate those when really they should be invisible to a normal user, and someone who's just browsing the site normally wouldn't even see those, let alone tamper with them. So those are kind of the 4 steps, and now we'll kind of walk into some of the more granular details about what these things are and how they work. So first, we're back to the violations, and kind of as I mentioned, violations are just instances that we've identified of bad behavior. And what we'll do is we'll track those over time. So each time an attacker or a user does something that we identify as a violation, we'll essentially log it into our database, and we will track that. Again, these can be triggered by things like bad paths, so /admin or some type of an exploit string, cross-site scripting, or SQL injection in a parameter, or tampering with a trap. And we'll talk about configurations, but each of these can be weighted so that if it's something like it's clearly a SQL injection attempt, maybe we'll weight that a lot higher than someone hitting a 404 page and just reaching a page that's no longer there or isn't there. Because what we really want to do is make sure that we're not punishing or making the site not work for users who are just browsing the site normally. And we wanted to kind of inject a note on violations and authorizations. So one of the really cool and I think important things that you can do with Ensnare is you can hook this into your existing authorization logic. So, if you've developed your application in a secure way, you should already have checks in place to say, is this user trying to access another user's bank account? Is this user trying to access some data that they shouldn't have access to? So you should already be able to identify that and respond to that in some way by sending back a 500 or a 401 or whatever your application does in those circumstances. But what Ensnare allows you to do is essentially hook into the Ensnare framework and say we've identified an authorization violation, and then we can handle them through all of the response capabilities that Ensnare provides as well. And that's really easy to do. You can do that with one line of code in one of your controllers. When you're rendering back a response. And just to kind of briefly mention again, violations are tracked based on a combination or any of IP address, session ID, and user ID. So what we've attempted to do is make it so that we have some ability to track users across their different sessions, across their different movements, if they're changing IP addresses or if they're coming through Tor, for example. And we're trying to make it as persistent as possible. Any violations that are identified are stored in a database, and then we can essentially query those to see how many have happened over time for each user or for each IP address or session. So the next piece to circle back to is the threshold. So this is, again, trying to identify how bad the attacker actually is. Is this someone who's just a normal user, or is this someone who's attacking the site? And the threshold configuration allows great flexibility and granularity. Essentially, these can be set up in any combination you want them to be. It allows very powerful state handling because you can do things from trying to confuse the attacker. So maybe they're trying some SQL injection attempts and they're getting back responses indicating they're not working, but then all of a sudden they start getting back 500 error messages, which would be really confusing because sometimes that indicates you've triggered some type of an exception. So they keep testing it, and then all of a sudden they're getting 404s back, and then it goes back to acting normal, and they just can't figure out exactly what's going on. So you can make it so it's somewhat random. You can make it so they move through different thresholds in different states. And the goal here is to create false negatives or false positives for the user while having no impact on actual legitimate users. And thresholds can be configured in a few different ways. So the first one would be the trap count. So this is essentially how many traps or violations have they accrued during their time that we've been monitoring them on the site. How long have they been in this threshold? So how long has it been since we've last seen a violation from them? And then the other part is the responses that we want to send back. So we have a quick example that we can walk through. Hopefully you guys can read this diagram. Up at the top we have a little attacker who is browsing our website, and he's sending attacks. He's sending some SQL injection attacks towards our site. And once he reaches 5 violations, so he's sent 5 bad requests or 5 exploit strings to the site, we're going to move him into trap threshold 1. And we're going to keep him there for 600 seconds. And what this means is we're going to use the following different response types. For 20% of his requests, we're going to delay him for 10 to 15 seconds. So we're going to inject a random delay in the response. For 30% of the responses, we're going to redirect him back to the root, right? So we're basically going to just redirect him regardless of what he's trying to do. He's going to end back at the root of the home page. And then for the other 50%, we're going to do nothing, meaning we're just going to render the response back as normal. So you can kind of imagine that this is going to get, number one, frustrating because you're trying to test, is this exploit string going to work here for cross-site scripting, or is this parameter SQL injectable? And you can't get a good read on it because the response you get back keeps changing. But anyways, the attacker is persistent. He keeps trying, and he gets up to a violation count of 20. And at that point, we're going to move him into trap threshold number 2. And we're going to keep him there for 1,600 seconds after his last violation is logged. And so in this response group, what we're going to do is 60% of the time we're going to delay him for 20 seconds. So now it's going to take him a lot longer to actually perform any of his tests because he's going to be delayed significantly a lot of the time. 20% of the time we're going to give him 500 error messages back. So regardless of what he's requesting, he's just going to get a 500 error. And then the other 20% will do nothing, meaning render the response again. So this is just kind of a sample of how this could be configured. It's really completely customizable and flexible. This is kind of an example config file where we have 3 different threshold groups set up. And you can kind of see here, if you look at the top one, the timer is set to 600 seconds. There's a trap count of 5, so we'll start triggering these responses after someone reaches 5 traps or violations. And then the responses we'll send back are the redirect 50% of the time, the throttling 20% of the time, and nothing 10% of the time. So this is just an example config file. You can have as many or as few of these as you want, and each one can have as many or as few responses as you want. So speaking of responses, what exactly are they? They're really just a technique or techniques used to prevent someone from being successful in attacking your website. So things we might want to do. Maybe we want to slow the attacker down by throttling them, so it takes a really long time to get that response back if they're trying to see if something is cross-site scriptable. Maybe we want to alert them that you've identified the attack. So maybe you would pop up a message to them on the screen saying, hey, we know what you're doing, we'd appreciate if you stop, or we've alerted the security team, they're aware of your behavior. Maybe we want to block the attacker completely. So we could just send back 500 messages. We could redirect them to Disney.com. We could send back 404s. We could do any of those things just to say, you know, get off our site. We're not really interested in your traffic anymore. Maybe we do want to alert the security team. So we'll send out an email so that people know that the site's potentially under attack. Maybe we want to annoy the attackers. So maybe every other request we'll put up a CAPTCHA that they have to solve if they want to continue using the site. Or maybe we want to hack the hacker. So maybe we want to inject a beef hook and start collecting data back from the attacker and figure out who they are, where they're coming from, and take over their system or something, right? We didn't implement that, but it's just an example of something you could do if you wanted to do. Right. So all of these responses have various configuration settings. So for example, we talked earlier that there's options for things like the throttle. You can give them a range of time periods you want to throttle the user between 2 and 10 seconds, for example. Every response can be weighted, so it happens a random percentage of the time so that it looks funny. Or you could make it happen every time if you wanted. So like I said, if you wanted to just send back 500 error messages, once an attacker reaches a certain threshold of badness, you can do that as well. And then also each request can trigger multiple responses. So you could imagine something where you throttle the user 10 seconds, you make them solve a CAPTCHA, and then you give them a 404 page, right? So you could be really obnoxious with this if you wanted to. And then the last part, the last of the steps that Ensnare does before rendering the response back is setting up the traps. And just to go into a little more detail about what the traps are, they're basically injected tests that we can use to check for violations. And we've talked about a couple other types of violations before, things like signature-based or bad paths and things like that. So not all violations require traps, but this is just an optional extra part that you can go a little farther and try to entice people to actually attack your site so that you can identify somewhat early on that these are potentially malicious people. And we thought a little bit about kind of the intelligence of how you want to design these. I think the obvious thing to do is to do very lucrative names like debug or admin or UID and have those as cookie values or parameter values and try to trick people into changing those so that you can identify them trying to bypass your authorization controls. You can also do things like put benign or random type of names for these things in there. Because again, if they look out of place, there's a good chance that an attacker, especially a manual attacker, will start playing with these. And if it's an automated scan, it's probably going to essentially brute force everything anyways, so it will definitely pick up on them. But the point is really to draw the attention of someone malicious while not drawing the attention of someone who's just legitimately using the site. And we built in some different cookies and parameters that you can enable with essentially just one line. You can also do totally custom ones, and you can set them up to custom random values. You can specify custom algorithms to generate those values so that it looks totally unique to your site. And now we have a quick demo that Scott's going to walk through.
Cool. All right, so for our demo here, where's the space? 1 second here. That'll do. All right, for our demo here, you kind of see I'm just logging into the site. We have this site. It's like a recipe book. So I logged in. I created an account. Awesome name right there, or 1 equals 1, right? So I'm adding some comments and just kind of showing this is a really basic site. The user using this site, not very security conscious, decided to go ahead and add Ensnare to their site. So I'm just kind of browsing around. I'm doing my usual thing. I'm filling up my proxy logs. So I kind of want to look at requests potentially and where things are going in the site, adding some comments. There's the concept of different users on this site, so that's kind of interesting. So the next thing I'm doing is I'm going ahead and taking a look at one of the requests to actually see what kind of cookies are being set. And here's a variety of cookies that were actually created and set by Ensnare. Now, it might be a little hard to read in the back, but there's also some post parameters I'm looking at here for this particular model, which is the comment model. There's this one cookie called uTrack. This looks like a tracking cookie. So I'm going to go ahead and send that over to Repeater. And I'm going to change the value of this particular parameter, which looks to have some hex string or something in it. So I go ahead and change that parameter to fuzzing this, and I go ahead and send the request along. And then what ends up happening here is I get a 302. It says I'm being redirected to a particular page. So that's strange. Let's go ahead and follow that redirect. I'm being redirected again to another page. Let's go ahead and potentially follow that redirect. I'm being redirected to another page. Does anybody have any idea what's going on here? I'm actually in a redirect loop. Which is super annoying if you're ever testing an application and it fills up your proxy log. It's super obnoxious. So I'm going to go ahead and, I'm a little confused. I'm going to go ahead and refresh the page. Oh, I'm getting the page isn't redirecting properly. Error message in Firefox. So I know I've done something I potentially shouldn't have. Next thing I'm doing here is I'm going to attempt to do another attack on the page. I'm a little confused on what's going on with the app. Let's go ahead and attack again. This time I'm going to try to post to this recipe 6 because I believe this is a recipe that I'm not a manager of, but I'm going to go ahead and try to potentially update that page even though I don't have write access to it. Basically exploit a direct object reference vulnerability. So I go ahead and attempt to exploit that. I get a 404 not found. Oh, that's interesting because I'm pretty sure that page was there. It wasn't kind of the error I was expecting to see. Let me go back to the root of the site. Weird, I got another 404. We go back to the root. Oh, now the site loaded up. Okay, that's cool. Let me go back. I'm going to try to visit another page here. It's taking forever. The site is not loading. And I got another redirect loop. Okay, so I've created some really strange state with the application. Now, as the person administering this site, we can actually take a look at some basic metrics here. We have a dashboard that allows you to kind of track and see what's going on, so we can see where the violation types are occurring. Are they occurring in parameters? Are they occurring in bad paths? Are they authorization vulnerabilities? Because we talked about that ability to hook into existing authorization checks within your code. Are they cookie violations? And where are the source of these violations coming from? We can look at the IP addresses, the sessions, or the user objects. I can actually go into the violations table and look at exactly where the violation occurred and what time. I can see the value that was expected, the value that I observed, as well as the weight of the violation. For example, we're really concerned about authorization vulnerabilities, so we make sure to increase the weight of those violation count. And I can kind of scan through here and basically take a look at what's going on. There's other options too. The configuration option just gives you some example configurations that you could potentially implement in your application if you want to. And I encourage you guys, when you check the project out, to just play around in the dashboard and all that good stuff. Cool. So we kind of have like a little bit of a CTF going on right now. This is a site. We'd love for you guys to play with it. It's ensnare.herokuapp.com. This is not a production app. Like that recipe site, if you saw it, it's janky as hell, okay? You can literally create names with special characters in them. So we threw it together really quick. It might be unstable. Please don't try to knock it down. Like, don't DOS the site. That's not fun, right? And then nobody will be able to have a good time with it. Scanners are okay, though, if you want to run burp or app scan or something against it. And I will give you extra points for authorization attacks because that would be awesome. So if you guys do get some vulns going, let me know. If you find it super annoying, hit me up on Twitter. I'd love to hear about it. And so one of the questions we got asked, we were kind of thinking about when we were originally writing this is, what kind of latency is this going to add in the entire process? So we derived these metrics using YSlow, and we determined that on a native application, the average difference in response time was 6.7%. That might sound like a lot, but when we're talking about the average network latency on the web, 6.7% is very, very, very small. It's like an average delay of maybe 10 milliseconds. So unless you're providing some sort of mission-critical application on a dedicated network that has no jitter or latency, we think that this is pretty acceptable. But yeah, this was tested out, and it's roughly right around 6%. So what's a deployment strategy with Ensnare? We have some documentation that's pretty fleshed out, kind of walks you through exactly how to set it up and work it into your application. We included an example configuration file that you basically copy into your application to turn Ensnare on. There's more configuration examples in the dashboard, and they're kind of annotated so you know how to use them. And we encourage you guys at some point to customize the configurations, but you can use the example once it gets started. We definitely encourage starting in log-only mode. You do not want to be 301 redirecting or redirecting people to Disney.com if they're legitimate users. So play in log-only mode. Make sure you have a good idea of where you should be causing these responses to occur. Make sure your trap violations make sense. And once you get all the tweaks set up, turn it on enforce mode. Let it rip and screw with the attackers. And so some final thoughts on Ensnare. This is obscurity, right, in a certain sense. At least the honey trap stuff is. And I think in the security industry, we think of security, we say, oh, it's not security. But my thought is that, it's really just an additional layer on top of secure coding. And if I can filter out even one attacker from my site because they're trying to run a SQL injection scan and they keep getting redirected and delayed, I really think it becomes as effective as a WAF. Like if we can cut some of the noise out, it is an effective tool. And Ensnare is actually, even though a big chunk of it is the obscurity with the honey trap stuff, it's also, in its own sense, just a more advanced way in monitoring attacks. If I have the ability to hook into existing authorization functionality in my application and make smart decisions on that, I think there's a lot of value in that. I mean, within the application layer, we have so much data where we could potentially collect. And oftentimes, when I try to access your profile to perform a direct object reference vuln, I might just get an error message back, but that's really interesting stuff. That's something that we should know about. And we can abstract that out, log that in Ensnare, and let Ensnare actually handle that logic. And I think that that's something that's really powerful because we already do so much of this stuff in the code. Why not not take that data and actually do something with it? So there is some stuff we still have yet to do. We do not have a Rails 4 edition. The current version only works in Rails 3. We also would like some more trap types, especially Git parameters. So right now we can't set honey trap in Git parameters. It just works in post. Also think other headers would be useful. It'd be cool to set arbitrary headers and stuff like that besides cookies. Also have this idea of threshold start delay. This was something I came up with in the event that you get moved into a threshold group. So you're running a SQL injection attack. I would like to delay when the threshold timer starts and the user gets in. So you hit your 10th request, SQL injection, you're in a threshold group. Then you browse the site for like another 5 minutes, and then boom, it turns on the threshold. So that way they won't be able to correlate which request potentially put them in an event state change within the application. I think that'll make it super hard to identify when you've actually caused a state change in the application. We'd also like to implement whitelisting, because obviously there's going to be some legitimate times where you're going to want to potentially run an assessment or run a scan against your site. And just more response types, like somebody should write that beef hook. That would be really cool. Or maybe work in Metasploit Java payload, like to trigger when a user does something really bad. That could also be kind of fun. So just a couple caveats. There is no traps on Git parameters. We do not have test coverage. We didn't write unit tests for this. If somebody wants to do that, that'd be cool. It's like the most not fun thing in the world. So, and then just a couple configuration caveats. You know, the trap names need to be intelligent. If you're setting traps that don't make sense based on the application flow in your, you know, if you're going through a shopping cart and like your trap names have nothing to do with your shopping cart system, users might not trigger those. They might think something fishy's going on. And the same goes with your threshold groups. Like, be smart about exactly when you place somebody into a threshold group and what kind of responses you do. You want to ensure you're not affecting the legitimate user's experience on your site. And with that, do we have any questions? Yes?
What's the point of rate limiting and confusing an attacker? I mean, is the point just to let, I mean, the vulnerability, if it's there, it's still there, right? So unless you're repelling a DOS, I mean, is it just to let your own pen testing catch up to the pace of development, or what?
I think there's kind of a couple uses.